Good evening, scientists. And this evening we are going to be conducting a lesson called Bubbles Raising Raisins. And this is adapted from Section 3, Physical Science, and a Head Start on Science. The focus is second grade. The standards include 2-PS1-1, 2-PS1-2, Common Core Standard 3.2.2.B.7, Common Core Standard 1.4.2.H, and Common Core Standard 1.4.2.1. The materials we are going to need for this lesson are at least 2 small boxes of raisins, doesn't matter what type. Either popcorn kernels, macaroni, dried beans, whatever you can find in your house. Don't stress yourself out. We also will need 2 to 4 clear plastic cups. Make sure the sides are straight and not curved, just like that. And these little short guys work best. And we're also going to need cold, clear, bubbly, and recently uncapped soda. So today I'm going to use Canada Dry tonic water that's been super chilled in the fridge for a couple days. And those are the materials you're going to need today. So, to engage my students, to first engage them in the lesson, I will have them watch a Bill Nye video, of course. What else? And the video is called Playing with Bubbles. The video will help them grasp that there is carbon dioxide, also known as CO2, in soda, and this CO2 causes changes in certain substances or objects. I will then say to them, think about when the soda you drink has the most bubbles. Is it right after you open it, or is it right after you let it sit a while? Why do you think that is? Students should write down their thoughts. Also, included in the material so they can do this, a piece of lined paper to write down their thoughts, record their thoughts, and a blank sheet of paper to draw a model of what is going on in the experiment. Because it is important to record in as many ways as possible so we can get as much information as possible. And again, the video for Bill Nye will be included underneath this lesson. So, to explore, after the students are done brainstorming, thinking about when their soda has the most bubbles, I will pour the cold, bubbly soda into each pair's glass. I'm going to have the class break up, or whatever group I'm teaching this lesson to. I'll have them break up into pairs like I did my last lesson. So I'm going to pour the cold, bubbly soda into each pair's glass until it's 3/4 of the way full, no more. I will have children drop 3 to 5 raisins into the soda and wait. Don't do anything after that. The raisins will sink at first, but then rise and dance while the soda is bubbling. Questions I will ask to guide my students include, what are those things going up in the soda? Of course, it's going to be the bubbles, but we want to ask them what they think is going on. Number 2, what is happening to the raisins? Number 3, what do you see on the raisins? And the students will see the tiny little bubbles. It's the gas, the CO2 being released by the bubbles. And then also, I'm going to say, I wonder what is making the raisins go up and down. What do you think? Alright. Then, I will explain that the bubbles on the raisins have something to do with the rising and falling of them. Also, I will explain that the bubbles will eventually stop forming because all the CO2 gas has been released, and because of this, the raisins will stop dancing and moving. Lastly, I will explain that the CO2 gas in soda is also called carbonation. To elaborate on this lesson, I will have students try using different objects to test to see if they can dance in the bubbly soda in a similar manner of the raisins. So again, you can use popcorn kernels, you can use dried macaroni, dried beans, anything small and light and similar structure and mass to the raisin. And really anything else the students propose to test. And this is what you should be looking for if you conduct this lesson, paying attention to which students propose new materials to use, anything a little bit different, because it lets you know that the wheels are turning and that they're thinking. Children should, again, record their findings on their sheet of paper, on their lined sheet of paper. And I will have students, draw their cup of water with the objects in it and where the bubbles are, just so they can see the relation to both and how the different materials react with the CO2 and the bubbles. So, I will quickly demonstrate this for you, and then I will tell how the evaluation will go. So again, you're going to need one of these clear cups, a nice cold, clear, bubbly substance, preferably tonic water, club soda. That should work the best. See the nice bubbles? And you're going to pour it about 3/4 of the way up. And we have some nice fizzy bubbly soda there, so that is perfect. And we're going to grab, again, 3 to 5 raisins, no more. I'm going to do 3 and see what happens. So 1, 2, 3. Again, they're going to stay up, but you see them pop up. And this is because of the CO2. You see them dancing along at the bottom there. All that CO2 is being released. And the gas bubbles are forming and then rising. You can see. We're going to wait for our raisins to do a little bit more. You can see them dancing at the bottom. You can hear those bubbles. That's how you know you have some good carbonated soda, which is what you want. There we go. There's number 2. It does its little dance. And maybe number 3 will happen. And what you want to point out to your students is the gas bubbles forming around the raisin, and this is what's helping lift the raisins up. The pressure and the gas is helping push them to the surface. See if we get number 3. Should work. It's almost there. You see it starts to move and lift up. Might not work this time. Well, we had our 2 out of 3, and that's really what you want. You want the students to get the idea, the concept. And this is a really fun, easy, there we go, there's another one. This is a really fun, easy experiment that you can do to introduce students to gas and pressure and bubbles. And again, that Bill Nye video, he never fails. He will definitely help clarify a couple concepts for your students. So he is not a bad way to go, and that's why I always include him in a lot of my lessons. He's pretty simple for students to understand. So, after we do this with the kids, after you do this with your students, to elaborate, after I do it with my students to elaborate, I will have students try to use different objects to test to see if they dance in the bubbly soda in a similar manner of the raisins. You know what? I already did that. So, that's elaborating. To evaluate. So again, do your raisins first. Then test out different objects like macaroni, dried beans, anything in similar mass and appearance to raisins. And then record your findings, have the students record their findings. Lastly, to evaluate, students will be evaluated on the basis of, number 1, how eagerly they inquire about the activity at hand. So if they're really, really excited, that shows you that they're taking initiative, and that's really what you want to see. Number 2, their level of participation. Even though they're eager, they might not do that much. So you want to see that they're recording what they find and they're drawing a model of what they see and drawing a model of the bubbles and where the bubbles are in relation to the raisins. They should be on the raisins. That's one of the things you should be looking for in their drawings, their models. 3, if they ask sufficient and educated questions. So if they ask, you know, what causes the bubbles to rise, and why are the bubbles in there? Why does the soda have so many bubbles? And again, you can review carbonation and talk about gas and carbon dioxide. And number 4, lastly, if they propose to try the new objects that you give them in the soda. So they're not just doing the basic lesson, they're doing more than what is required. That's the last thing that I'm really going to be looking for to evaluate. And if they go above and beyond for all 4 of these steps, they're going to get a great grade. They're going to get the top grade. So that is Bubbles Raising Raisins from A Head Start on Science. So have fun, my little scientists, and I will see you next time. Bye.